Hello, lovelies. Today we are going to talk about another way that we can solve for missing parts of non-right or oblique triangles. So this is Law of Cosines. You may have remembered from our Law of Sines lesson, there were a couple cases of oblique triangles that we could not use Law of Sines for, and that's why we have Law of Cosines. So basically, this is another law we can use in order to find missing pieces of a triangle. And the information that we will be given is going to be side, side, side. Notice there's no angle given, which means we can't use Law of Sines because we needed a full ratio to use Law of Sines, which was an angle and a side pair, right, an opposite side pair. So if we're only given three sides, obviously we don't have an angle, can't use Law of Sines for that one. Also, if we're given side, angle, side, so an included angle, an angle between the two given sides, then we also don't have an angle and the opposite side pair. So these two cases, we're going to need to use Law of Cosines. It's slightly more complicated than Law of Sines, so you do want to be aware of when you can use Law of Sines because it's easier. So we want to use the easier thing when we can, right? Let's work efficiently. So pay attention to that. You do want to be looking out for those side, 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 or side, angle, side given information, and that's when we're going to use this. Okay, so depending on what the given information is, you will use one of these three equations here. They're all the same. Okay, it just rearranges the pair, but they all follow the same pattern. You really only need to understand one of them in order to be able to use all of them. So let's go through this first example. All right, so a squared, that's this side right here. So we start with the squared side, and notice opposite that at the very end of this equation, we have the cosine of the angle opposite that side. Okay, so if we start with side A, then we have to have cosine of angle A at the end of our statement. Now, if, however, we started with angle or side B, right? Maybe we're starting with side B over here, then on the opposite side at the end of my equation will be cosine B, opposite my side that's on the opposite side of the equation. So remember, angles and their opposite sides often have always have a special relationship, right? This is the thing we know about triangles. That angle dictates how big or small that side can be. So when you're setting up your Law of Cosines equation, you're always going to take your opposite side and your opposite angle. Those will be on opposing sides of the equal sign, okay? And then the rest is just taking the rest of those pieces of information, the other two sides, and plugging them into this formula. So the formula is a squared, whichever side is opposite the angle in question. So in this case, in this first example, we're either given this side or this angle, and that dictates that we have to set it up for this first one right here. So we're going to be using this first setup here. All right, so we're going to start with the side we have opposite the angle. We're going to square it. We're going to set that equal to the other two sides squared and added together. Notice when we talk about addition, order doesn't matter. So it could be c squared plus b squared. Really does not matter, okay? And then we're going to subtract. So notice all of this gets subtracted. So we're going to multiply 2 times those two sides. Notice those are the same. So your opposite side gets used once. Your other two sides are going to be used multiple times on the same side of the equation, okay? And then we're going to take the cosine of that angle. This will make a whole lot more sense when we actually apply it, but definitely an equation or a formula rather that you want to have readily available while you're working on this. Okay, so how does this work? Why do we care? Let's figure it out. All right, if we want to solve for BC, I'm going to call that A because it's opposite my angle A over here. All right, well, notice I'm given side, angle, side. I do not have an angle and the opposite side. I don't have that pair available to me, so I have to use Law of Cosines, and this is that first example because what we're looking for is side A. We're given the opposite angle A, so we're going to set this equation up with A squared equals, and then we're going to be able to solve this. So A squared, the side that we want to solve for, is going to be equal to the other two sides squared and added together. So order doesn't really matter because, again, we're adding. So Doesn't matter which one we do first. All right. And then we're going to subtract 2 times both those sides, 30 times 21, all being multiplied by the cosine of this angle here, which is 123. Okay, that looks really ugly, but this is just a calculator problem. Notice everything is on the same side of the equation. We've already isolated what we're solving for. A squared is over here. I mean, we'll have to take the square root in the end, but it's pretty much by itself. So this is actually a relatively straightforward problem. You definitely want access to a graphing calculator or Desmos for this. So this is seriously, you can plug it all in across the line. 30 squared plus 21 squared minus all of this. So minus 2 times 30 times 21 times the cosine of 123. And again, make sure your calculator is in degrees, equals. Okay, so we get some ginormous number, which makes sense because we're about to take the square root of this business. Okay, so we get a squared is equal to about 2027.25 when I round. Then I have to take the square root of both sides to isolate my a and actually get it all by itself. Square root, and I get that a is about 45.02. Now let's ask ourselves if our answer makes sense. This side A is opposite a very obtuse angle here, right? 123 degrees. So it's definitely going to be my longest side because the other two sides are, or the other two angles are acute. So angle or side A should definitely be the longest. It's 45. That's definitely longer than 21 and 30. Looking good to me. Now, if you had to solve for all the missing parts of this triangle at this point, you could now use law of sines because now you do have a side and its opposite angle. So you could actually take law of sines now and apply it to find the rest of the missing parts. So really, you should never have to use law of cosines more than once, even if you're solving for all missing pieces of the triangle. All right, give this one a shot. See if you can look at the formula, plug in the pieces, solve for what you're solving for. All right, in this case, we're solving for c. So c squared is going to go on the left-hand side of my equation. That's going to be equal to these other two sides squared and added together, 20 squared plus 22 squared. Then I'm going to subtract 2 times both of those values, 20 and 22. And I'm going to multiply that by the cosine of that angle opposite the side I'm solving for, 95. Okay, again, straight plug into your calculator. You can do it all in one line. Of course, you can do it pieces as well if you like, but this is pretty straightforward calculator work. Don't forget you're subtracting all of this, 2 times 20 times 22 times the cosine of 95. And again, making sure that your calculator is, of course, in degrees. Then, okay, so that gives us c squared is equal to, and this is about 960.6907. I would have had to round up if I had stopped there. So then we're going to take the square root of both sides, and we get that c is about 30.9. Oh, when we round, it's going to end up being about 31. So this is going to be about 31. Okay, again, does that answer make sense? 95 is also an obtuse angle, so it should be opposite the biggest side here. Not quite as big a discrepancy because 95 is smaller than 123 like that last one. So does 31 make sense in the context of this problem? Yep, looks pretty good to me. All right, so let's try this one. Now we're solving for an angle. This is a little bit more complicated because now we're going to have we're going to have to isolate that cosine of that angle A. It's a little bit uglier, but totally doable. So remember, we're solving for this angle here. So first thing we want to do is spot the opposite side because we're going to have to use that on the left-hand side of our equal sign. So 14 squared is going to be equal to 9 squared plus 6 squared, my other two sides, minus 2 times 9 times 6 times the cosine of now A. Okay, so that's the piece that we are solving for. So we're going to have to isolate that piece right there. I will tell you right now, this is where students get into trouble because they mess up order of operations. So be very careful and intentional and you'll be just fine. we're going to start with 14 squared, which is, of course, 196, equals 81 plus 36 minus, we're going to do, remember, we're going to keep this, you can multiply 2 times 9 times 6, that's fine, but then we're going to have to stop because we, of course, have to deal with this cosine A here. Okay, so 108 times the cosine of A. Notice all of this right here, in fact, let's highlight it, all of this right here is being subtracted from 81 and 36. So step one, let's move those to the other side of equal sign. So we're going to subtract 81, we're going to subtract 36, subtract 81, subtract 36, right? So we're going to take 196, we're going to subtract, we are going to subtract our 81 and our 36, and we're going to get 52 equals, well, now these things are gone, right? Negative 108. Oops, that's 180. Try again. 108 times the cosine of A. All right, well, how do I undo this multiplication? I'm multiplying negative 108 by the cosine of A, so I need to divide by negative 108 on both sides. Divide by 108 on both sides. So now I have 52 divided by negative 108, and that's going to give me negative 0.48, blah, 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 right? So we get negative 0.48 something, something, something equals the cosine of A. And now I need to undo cosine. To undo cosine, we need inverse trig. So we're going to do cosine negative 1 of negative 0.48, blah, 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 blah. And that will give us our angle A. So we're going to, of course, keep that in your calculator so that you can get a more precise value. So cosine negative 1 of our answer from the previous work that we did is going to give us about 118 degrees, 0.78. So this was A, right? So the measure of angle A is approximately 118.78 degrees. Okay, now let's ask ourselves if that answer makes sense. Angle A should be our biggest angle because it's opposite our longest side. So it makes sense that it would have an obtuse angle. That's looking pretty good to me. All right, of course, you are going to try this other problem, but I, to save some time on this video, already did it for you. So let's walk through what we did. This time we are also solving for angle A. So we want to set it up using our opposite side. 10 is going to go on the left-hand side of our equation. 10 squared equals my other two sides squared and added together. That's 11 and 17 in this case, minus 2 times those values. 2 times 17 times 11 times the cosine of A. So again, we want to move everything to the left. So we're going to subtract 289, which is 17 squared. We're going to subtract 121, which is 11 squared, from 100, which was our 10 squared. So now we have negative 310 equals negative 374 times the cosine of A. Okay, again, because we had 2 times 11 times 17, which gives us negative 374. Okay, we need to isolate cosine A, so we're going to divide by negative 374 on both sides. That gives me positive 0.829 is the cosine of A. We need to arc cosine, isolate that angle there. When we do arc cosine, angle A is approximately 34.02 degrees. Now, if we look over here, does that answer make sense? It is opposite the shortest side. So it definitely should not be an obtuse angle. It should be an acute angle here. And it is 34 degrees. So that answer makes sense to me. Looking good. Okay, so now remember what I said about working smarter, not harder. Make sure you're looking at given information and seeing which law you can use because, again, law of sines is a little bit easier. Okay, so if we look at this example here, I have an angle and an opposite side, so that's good. And what I'm solving for is the angle opposite my other side. Ding, ding, ding. This is a law of sines. So we're going to do sine of 112 divided by its opposite side of 25 is going to be equal to sine of x, we don't know what this is yet, divided by 12, its opposite side. So now we're just going to plug this into our calculator, sine of 112. We're going to multiply that by 12, cross multiply here, right? Whoops, don't do that. When I was doing that in the calculator, it went inside the parentheses with my sine 112, That would not be the same. Make sure you end that parentheses before you multiply by 12. And then we need to divide by 25. So again, what I did was 12 times the sine of 112 is equal to 25 times the sine of x. Then, of course, we divide by 25 on both sides. And we get the sine of x is equal to 0.445. Okay, how do we solve for an angle? Arc sine. So now we're going to do sine -1 of that whole answer, 0.445, blah, blah, blah. Of course, keep it in your calculator to get the best possible answer, and that will give you your angle x here. So arc sine of that value that we have stored in our calculator, and we get 26.426. So we get that the measure of angle x is approximately 26.43 if we round degrees. Okay, does that answer make sense? Well, 12 is definitely not my longest side, so I expect this to be an acute angle, especially given that we have an obtuse angle of 112 here. So 26.43 looks good to me. Okay, you're going to try this one, of course, see what information is given, and then attempt the problem. All right, so we look at this triangle and we see, okay, we have an angle, and we're looking for the opposite side over here. So far I'm thinking, yeah, law of sines. Oh, but then I don't have any actual ratio to use, right? I don't have any other angles. I can't use triangle sum theorem because I'm missing 2 angles. So this is a side angle side or a law of cosines problem. So I want to solve for that angle or that side x. So I'm going to put that on the left side of my equation. And then at the very end, we're going to have cosine of 87, the angle opposite it. And then, of course, we're filling in these other sides. So we're going to get x squared equals 16 squared plus 15 squared, my other 2 sides, minus 2 times those 2 values times the cosine of the angle, 87. Again, this is real easy. Just plug straight into your calculator. Everything on the right-hand side gives you 455.87 approximately, of course. Then we still need to take the square root of the left, square root of the right, and we get that x is about 21.35. Does that answer make sense? It is the longest side of our triangle. 21.35 would be the longest side of this triangle. Looking good. All right, let's look at this one. Okay, I'm solving for this piece here. I have 2 angles, which means I could definitely solve for this other angle over here, right? So I can take 180, subtract 108, subtract 40, and that'll tell me that angle right there. So I know I have all my angles, which means I can definitely use law of sines here. So fantastic, let's do that. We're going to take our 180, we're going to subtract our 40, we're going to subtract our 108. It's going to tell us that this angle is 32 degrees. 32 degrees. Great. We want to solve for that opposite side, so we're going to do the sine of 32 over that side x is going to be equal to, now it doesn't really matter, could I use 108? No, I don't have that side. So now I have to use this one because that is the ratio that's complete, right? So we have sine of 40 divided by 20. Okay, we're going to cross multiply 20 times the sine of 32. It's going to be equal to x times the sine of 40. And then we're going to divide by the sine of 40 on both sides. And that will isolate my x. So 20 times the sine of 32 gives me approximately 10.59 divided by the sine of 40 gives me that x is about 16.5 when I round, 16.5. Let's see if that answer makes sense. We are opposite the smallest angle here, and I know opposite 40 is 20, so this should be smaller than 20, but not by a whole heap ton, because it's only 8 degrees different. So 16.5 looks good to me. All right, give this one a shot. All right, we have an angle and 2 sides, including that angle. So we do not have an opposite pair. This is going to, again, be law of cosine. See what you can do with this, set it up, and solve. So again, this is the easier version where we have b squared on the left and we have everything on the right. So we're just going to plug in these values. We know that the other 2 sides are 17 and 34. And so we plug all that information in. On the right-hand side, we get 15 or 1,525.64 approximately is equal to b squared. We take the square root of both sides and we get that the side B here is about 39.06. Okay, it's opposite our obtuse angle, so it should be the largest side, and it is larger than both 17 and 34. Looking good. Okay, on this challenge, I really do want you to try it. It's not that bad. I think you can do it. Just think about what you remember about some of your principles of geometry from last year. You got this. Okay, so that really big principle that you need to remember is that this is a line, and all lines add up, the degree measures add up to 180. So I found that this angle was 62 by taking 180 and subtracting 118. Now I can use law of sines because I'm looking for angle A, and I know that opposite angle A is 25 and opposite 62 is 35. So I can just set this up for law of sines and go ahead and solve. And it wasn't that bad. They gave you extra information to see what you would do with that, but really, you can just subtract from 180 and go to law of sines. Hope that all makes sense. Have a wonderful rest of your day.